Hi guys, in this video we will be learning about the basics of integration. What is integration? So we all know what derivatives are. Derivatives are basically when you differentiate a function and you get its derivative. That essentially means there is a unique tangent at any point, and the derivative at that point is basically the slope of that tangent, right? So there's a function whose derivative you figure out. Okay, so suppose you have a function x to the power n plus 1 upon n plus 1. The derivative of this function x to the power n plus 1 upon n plus 1 will actually be x n plus 1 minus 1 and n plus 1 here, and n plus 1 was there. So this cancels, and what do you get? You get x to the power n. So integrals are essentially entire of derivatives. So integrals are essentially entire of derivatives, which means that if I am differentiating x to the power n plus 1 upon n plus 1, I get x to the power n. That means if I will integrate x to the power n, I will get x to the power n plus 1 upon n plus 1. That's the relation between integration and differentiation. So derivatives and antiderivatives. Antiderivatives are integrals. So, and there would be plus c attached to it. I'll talk about what is c. And n should not be equal to minus 1 because then your denominator becomes 0. Similarly, or you can particularly also, note down here that particularly if you take d by dx of x, d by dx of x is 1. So that means in integral of 1 dx with respect to x basically will just be x plus c. Similarly, you can take some other function. So d by dx of sine x is cos x. So what can you say? Integral of cos x is equal to sine x plus c. D by dx of cos x is minus sine x. D by dx of cos x is minus sine x. Or in other words, to talk in terms of integrals now, let me just take that d by dx of minus cos x is sine x, because minus minus will make it positive. So which means that the derivative, the integral of sine x will be minus cos x plus c. And there can be many, many such examples. So what essentially is happening here, your derivative, the relation between derivative and antiderivative. So if you differentiate and you get something, a function of x, when you will integrate that function of x, you will get the function that you differentiated. That's the relation between the two. Similarly, we can take some more examples here. So d by dx of tan x is secant square x. So integral of secant square x is equal to tan x plus c. And there can be zillion such examples. Now this plus c, what is this plus c? What is this plus c all about? I'm going to take an example out here. Suppose the function is 2x. Then integral of 2x is basically x square plus c. Integral of 2x is x square plus c because, and that's happening because the derivative of, d by dx of x square is equal to 2x. But just try to realize one thing. Had it been d by dx, so d by dx of 2x is, or d by dx of x square is 2x. Had it been d by dx of x square minus 1, had it been x square minus 1, will the derivative be something else? The derivative will still be 2x. Had it been x square plus 1, the derivative will still be 2x. X square plus 2, x square minus 2, for all. Along with x square, if you have a constant, the derivative of that function will still be 2x. So that's the concept of that constant c that you add. Because when you add that constant c, add or subtract, it could be plus, minus, whichever way, the derivative turns out to be the same. Okay, the derivative turns out to be the same, and that's why when you integrate the entire, you take the case of plus c, because what's happening essentially is slope at any x equal to a is the same. The tangents would be parallel, even if they're not looking that parallel in my diagram, but they're actually parallel to each other. So, you can have different parabolas. This is x square. This is x square plus 1. This is x square plus 2. This is x square minus 1. This is x square minus 2. The parabolas will be like that, and the tangents will be parallel to each other at a particular point A. At x equal to A, it'll be parallel to each other. So having parallel means that the slope is same. The slope of all the tangents at a particular point to all these parabolas will be the same. The parabolas are different. They're x square plus 2, x square minus 2, and so on and so forth. So that's the reason why we put that constant c. The constant c, it's very important for us to understand that why we put constant c when we have an indefinite integral. Indefinite means an unbounded case. An unbounded case, you don't have any bounds to deal with. So that's the reason why we have that c. Because the slope, since derivative of constant is just 0, so the slope will be the same. So d by dx, integral fx dx is equal to fx, and integral f dash x dx. Integral f dash dx is equal to fx plus c. Integral f dash x dx is equal to fx plus c, because of the reason that I told you. So see, fx, the example we have taken, fx is x square. Then also your derivative is 2x. If it is x square plus 1, then also your derivative is 2x, and so on and so forth. This can be extended in the following way. If d by dx of integral fx dx is equal to d by dx of integral gx dx. If d by dx, if the derivative of integral of a function is same as derivative of integral of another function gx, then the two functions have to be the same. Then two functions integral have to be the same. Then the two functions integral have to be the same. If the derivative is same, then derivative of, now what are we looking at? We're looking at derivative of integrals. So if the derivatives are equal, then these functions are equal. So integral fx will be equal to integral gx here. Let's look at some examples now for simple integration. So the first example that I'm looking at is the following. Cos 2x. Integral cos 2x is equal to sine 2x upon 2 plus c. Why? Because the derivative of sine 2x by 2 is equal to, when you will differentiate, what will happen? 1 by 2 will remain outside just like that. You will differentiate, sine turns into cos. Since you have 2x, so 2 will come out. So you will have 2 here, 2 cancels, and you just get 2x. So that means when I am integrating, what is happening? When I'm integrating, cos 2x turns into sine 2x. But since you have a 2x here, so whatever comes with x will be in your denominator. Whatever constant comes with x will be in the denominator out here. Okay. Next example, x cube minus 1 upon x square dx. Now x cube minus 1 upon x square dx, using simple arithmetic, you can of course separate the terms here. So this will be x cube upon x square minus 1 upon x square. So you will just get x here and minus x to the power of minus 2. So when you will integrate, you will get x square upon 2 minus x to the power minus 2 plus 1 upon minus 2 plus 1 plus c. Plus c reason you all know. Now you know the reason. Plus c should be there. Now for this one, try to again understand that the derivative d by dx of x square by 2 will actually be 2x upon 2. So that will be x. So since that will be x, that is why integral of x is x square by 2. And the derivative of x to the power minus 1 upon minus 1 will be equal to x to the power minus 1 minus 1, and minus 1 comes out in product and minus 1 out here. That cancels and you just get x to the power minus 2. So that is why what you get x to the power minus 2 plus 1 upon minus 2 plus 1 plus c. Okay. Then let's talk about the methods. The first method, the simplest method for integration is the substitution method. So what do we do in substitution? What do we do in substitution? So if you see some function which you cannot directly integrate, so what you can do is you can just substitute taking another variable. For example, if you have sine mx, now you have mx. You don't have just sine x, you have integral of sine mx. So what I'm going to do is, I have to find out the integral sine mx dx. So I'm going to take mx as a new variable t, and that means m times dx. So differentiating on both the sides, So when you will differentiate on the left side, you will get m times dx. And differentiating on the right hand side will give you just dt. So that means dx is equal to dt by m. Dx is equal to dt by m. Now substitute. That's why it's called substitution. Substitute it here. So substitute it here. So you will get 1 upon m integral sine t dt. 1 upon m integral sine t dt. And when you will integrate it, what you will get? You will get minus cos t. That's because integral, just again remember, derivative d by dx of cos t of minus cos t is sine t. So therefore, integral of sine t is minus cos t and 1 upon m, which you have here, plus c. So the correct answer will be this. That's what is method of substitution. Next example, integral of tan to the power 4 root x sine secant square root x upon root x. Now, had it been in this question, had it been tan to the power 4x secant square x upon x dx, it would have been a different thing altogether. We would not have any problem. But this time it's not x, it's a function of x. So that is why substitution is something that we will take help from. So what we will do, we will substitute for root x. We will take root x as some t and then find out what dx will be. Then we will find out what dx turns out to be if I take root x as t. So we will convert the integral in terms of t, basically. So root x is equal to t. That means you differentiate on both the sides. Differentiating on both the sides, that would imply that 1 upon root x dx is equal to dt. Now substitute in the integral that you have here. So in the integral, it will become tan 4t secant square t. And since dx upon root x is twice dt, so in place of dx upon root x, we will write down twice dt. This is dx upon root x is equal to twice dt. So that's why 2 is here in the front and dt out here. Now again, there will be another substitution. Why? Because in order to solve tan to the power 4t secant square t, you will have to make another substitution to make it a little simpler for yourself. I'm sure you remember from differentiation that tan and secant square, they are related to each other. The derivative of tan is secant square. So hence the integral of secant square will be tan, right? So we can here substitute tan t equals to say some u. Now we will substitute in terms of, and we will turn the integral in terms of u. So you will differentiate on both the sides. That will imply secant square t dt is equal to du. So, you have a term for substitution, another substitution for secant square t dt, that will be du. So your integral now turns into twice of u to the power 4 du. Your integral turns into twice of u to the power 4 du, which basically means you will integrate and you will get u to the power 5 upon 5. And you have 2 along with it plus c. Now substitute for u is tan t. So substituting for u is tan t, and then next substituting for t is root x. So hence finally you will get the answer 2 by 5 tan to the power 5 root x plus c. Next example for substitution, integrate sine of tan inverse x upon 1 plus x square. So you do not have simply sine x here. You have sine of tan inverse x, right? So this calls for substitution. So what we will do, the simple thing would be to assume tan inverse x as some new variable, say t, and then convert everything to in terms of t. So that is, we will after substitution integrate with respect to t instead of with respect to x. So put tan inverse x as t, and 1 upon 1 plus x square dx is equal to dt. That implies 1 upon, because the derivative of tan inverse x is 1 upon 1 plus x square. So 1 upon 1 plus x square dx equals to dt. Now substituting it here for dx, clearly here dx upon 1 plus x square is equal to dt. I just have to substitute that here. So this becomes integral sine t dt. Integrating sine t dt is very simple. You will get minus of cos of t plus c. So that gives you minus cos tan inverse x plus c. Another example. Suppose I is cot x. So that is, you have to integrate cot x with respect to x. So integrate cot x dx. Now it itself is, it looks like just it's cot x, but it's a special case of substitution. Why? Because cot x is cos x upon sin x dx. And we know that cos and sine are related to each other in terms of derivative, right? So if you take sin x as t, you know that cos x is the derivative. So it will be dt. So cos x dx becomes dt. Substituting for sin x as t, cos x dx becomes dt. And hence you can easily just substitute that t dt is what you have to actually integrate. So 1 upon t dt you have to integrate. That makes it log of t mod t plus c, or in other words, log mod sine x plus c. One of the again, any special integral for trigonometric term is sort of special and important, because it will be dealt in a certain manner, and some specific answer would be there which probably you should remember, and maybe you don't have to again and again redo it. So integral cot x dx is directly, you can say, log mod sine x plus c. But again, if you do not remember it, you should just remember the methodology, how we have figured it out, and that methodology goes a long way. Similarly, suppose the integral is integrating secant x dx. Now, again, it's a special case. Integrating secant x dx, what we do, with just secant, I will not be able to do anything. Secant is 1 upon secant is 1 upon cos x, but I will not be able to integrate it just like that. So what we do when it comes to secant x, we multiply and divide by sec x plus tan x. We multiply and divide by sec x plus tan x, which in turn it gives us, if you multiply and divide by secant x plus tan x, what will happen? You assume secant x plus tan x to be t, and then when you will differentiate on both the sides, you will get secant sec x tan x, because the derivative of sec x is sec x tan x, and the derivative of tan x is sec square, that is secant square x, right? So you have secant x tan x plus secant square x dx, which is what is your numerator here. Numerator after this multiplication division is secant x tan x plus secant square x. So this dx equals to dt. In other words, again, I've taken secant common. So that means your numerator is dt. Your numerator is actually dt, and you just have to integrate 1 upon t dt. You just have to integrate 1 upon t dt. That will give you log mod t plus c. And what is t? T is secant x plus tan x. So this is also another very important integral, which probably you should remember the methodology and actually the answer itself. So integral of secant x is log secant x plus tan x plus c. But why so? The reason is, with substitution, you get that answer. With substitution, you get that answer. In the next video, we will talk about some particular functions, integrals of some particular functions.